Okay, yes, we're right at time. So thank you guys for joining. Today we're talking Edge AI. This is our next a second installment of our Transform Digest series. So this is these are popular topics from our annual Transform event. I know you guys have participated in Transform in the past, and certainly appreciate that. Appreciate having you here today. I'm not wearing my referee shirt today like I did last time, but if you guys saw the promo for this one, I got my cowbell, so this will be the signal to move to different topics. But again, appreciate joining. We've got folks filtering in. Encourage anyone on the chat, whether it's in the Q&A or just in the chat window, ask questions as we go, and we'll try to answer them during the course of the conversation. But with that, I'll introduce Huck and Bharath. Maybe you guys, if you want to do a quick background on yourselves, and then we'll kind of dive in on the conversation.
Sure. Jason, thank you so much. Bharat, great to reconnect with you. Absolutely. Let me see. Actually, I'm unmuted. Can you guys hear me?
Yes.
Okay, awesome. Sorry about that. Jason, thank you for the invite. Bharat, great to reconnect. I am actually with SAS at the moment, and even though we three have connected and have had past working on this very same topic, I'm still excited, and I feel like that we haven't scratched the surface yet on Edge AI. I happen to be head up the market strategy for AIoT. That's a term we coined, which I would love to go and take a double click on, working with a lot of customers worldwide. Especially, starting with those segments who are the early adopters of Edge AIs. Happen to also working with a lot of ecosystem partners, but very focused ecosystem partners who are helping us to enable Edge AI for the customers. Bharat?
Yeah, thanks, Huck. So, Bharat Ramesh, I head our AI inference software and solutions segment. And incidentally, I also was part of the team that bootstrapped our edge compute business here at Hewlett Packard Enterprise. So I'd postulate that we've actually been doing AI at the edge before we called it Edge AI and termed it as such. And it's been very interesting to see how that AI market and customer expectations have evolved over the past 7 years, from saying we can do everything in a gateway or a cloud to now actually demanding very similar capabilities with regards to AI that they get in the data center and cloud, but now get it at the edge. So it's going to be, I think, a very interesting discussion here as we look at some of the use cases and technologies that are enabling this.
Yeah, cool. Yeah, I mean, and it's, so there's a lot of, I think, confusion. I mean, obviously we're going to focus on the AI today. I think there's a lot of confusion still on edge and what is edge. And, I think probably 3 years ago, edge meant what I sell to you. That's the edge. Whatever business you are, that's the edge. But it is a continuum, and I think it'd be really good to kind of talk through some of those trade-offs as you go through. But in the interest of kind of just definitions, maybe we'll start with your definitions of edge AI, and kind of what are some of the boundaries. Maybe Huck, if you want to kind of take it from your perspective.
So and it's interesting that Bharat just referred to 7 years, right? When I refer back to what I would call IoT 1.0 end-to-end architecture, right? And so even though we started talking about edge to cloud 5-7 years ago, it was really cloud heavy, and there were just edge endpoints, right? And so how the data inferencing is really, AI inferencing is moving from cloud to edge. So going back a few years, right, when we started discussing edge, it was really revolving around that connected endpoints and not really truly edge AI per se, but bring data, collect the data and bring it back where it needed to be processed. Well, and then the scope and definition of edge started traveling, and that's how I interpret it. So early years, right, it was literally endpoints, and then get to the gateway. And then bring the data back as the infrastructure drives it. However, where we are today, we are really looking at true filtration of the data, right? just look at all the new requirements. These requirements existed, but these are, I referred to them as new because now we are having to hone down that how do we do edge analytics where the data is being generated. So I kind of take an approach, put myself in the customer shoes, right? What business outcome they're trying to drive. Even though it's edge AI, you can think of a horizontal sort of approach, depending on where the edge really is being defined by that customer. But it really gets down to that fact that what problem we're trying to solve. And that determines that what exactly edge AI is all about. So right now, so we look at, putting the customer at the center. We really look at where that edge AI needs to be sort of executed. So it revolves all the way, still that edge enable connected endpoints, gateways, and then we have started looking at infrastructures like HPC edge servers and other edge cloud infrastructures, which is still, that's where the edge AI inferencing is happening. So don't mean to labor, but that's definition and the scope of edge really varies as we anticipated even 5-7 years ago. So that's where we are, Jason. Bharat.
Yeah, it's funny. So when we first, I think, met, it was like, I would joke back then we were in the AOL stage of IoT, just get things connected online and gotta, dumb it down and get it connected, or pie in the sky mode, just Raspberry Pi and some cloud. But now people are, then you get the bill and realize you have to distribute stuff more. Bharat, how about from your perspective? And Huck mentioned inferencing, and so clearly that's a big part of this whole notion of AI. But even the other question is, will we also see training, extend out? And then there's a lot of different elements. So kind of how are you guys framing edge AI from an HPE standpoint, and the balance between things like training and inferencing and all that?
Sure. So we actually have a very simple definition of edge. It's anything that's not data center or cloud, any location specifically, right? Because when I think about the edge, what is it that's attractive? Why do we focus so much on the edge? It's because that's where the data is being generated. Because when you think about what is the data you're sensing at the edge, much of it is data in nature, right? Pressure, temperature, light, sound. And I always joke and say we're all walking around with sensors in our pockets, namely our phones, because my phone seems to know a heck of a lot about me. I mean, that's how every week I get this report from Google saying, Bharat, you've been to all these 20 locations, and here's how much time you spend there. And then I quickly go delete it before my wife gets to look at it. So my phone knows a heck of a lot about me because it's at the edge, it's sensing all this data from nature, and it's sensing and digitizing this in a very economical way, right? And the commercial side is not immune to this. I mean, you can get sensors for pennies on the dollar now compared to where we were just 10 years ago. So the data is now available, it's digitized, it's sitting at the edge. The question is, how are you going to process it? And historical approach where I'm going to hire a programmer who goes and writes code to go massage the data, it's not going to work because the data is very varied. The data types are different. The data is always changing. The velocity of the data is really high, because again, you're digitizing data from nature. It's always there. How precisely and how quickly you want to sense it, that's your choice. So we really see AI as being, the killer, the cutting edge technology, which helps customers analyze that data. And while a lot of customers started with this notion, as you said, hey, I can just take all this data, put it in the cloud and run AI on it. Now they're saying, I got to run it at the edge because it's just too much data. And it's data that's maybe personally identifiable or time critical, and I got to process it at the edge. So I want to do AI at the edge. I want to start with inferencing, which is taking trained models and getting a prediction out of it. But increasingly, I want to do everything AI related at the edge, which includes retraining the models and fine tuning the models. And so we have lots of interesting research we have done around training techniques like swarm learning. So we had we were on the cover of Nature in March this year, where we provided, a description of what we think swarm learning looks like and what kind of an architecture can be deployed in a, commercially viable way to do swarm learning. So we certainly see that, while today it's inference is really the hot topic that every customer wants to deploy, they're also thinking ahead and saying, okay, at some point I'm going to have to train, and I'm going to have to train it at the edge. How can I do that in an economical way? And they want to make sure they impute that when they deploy the architecture today.
Actually, Jason, to your point and to what Bharat just addressed, I was just discussing with a customer just a few days ago, this whole notion of training at the edge came up. And so from an analytics point of view, we have started looking at it, and the commercial viability is also important, right? It really depends on when you're doing online training as you are inferencing. It's still an almost like a nascent area, but now the customers are also looking at that in-stream analytics, right? Which truly didn't exist in the past. And so that's even though nascent net new areas, it's customers already asking about it, that how do I bring even the training in real-time online fashion at the edge? It's a very relevant topic.
Yeah, and it's interesting is yeah, definitely inferencing is the key now. Is a trained model you deploy and you make local decisions, filtering, etc. You know, this notion of training at the edge, certainly interesting. Then it's kind of comes down, I guess, the trade-off of in centralized locations, you have lots of data, you know, you got visibility, maybe you don't get into regional bias in terms of training, you know, locally, but there's that symbiotic relationship between the two that I think that we'll see. So, you know, I think there's not like a single answer. So the you know, when we're looking at kind of AI in general at the edge, what would you say is kind of the killer app, at least kind of initially from your perspective? Bharath, like I'm going to start with you.
Yeah, so every time somebody asks me what's the killer app for AI, it reminds me of an anecdote, right? So it's like in 2016, I was watching this CNBC interview with there's this company called Hanson Robotics, and you know, their goal is to build humanoid AI, basically robots that look and behave like humans, converse like humans. And so their CEO Dave Hanson's interviewing this robot called Sophia, and he asked her this question, Sophia, do you want to destroy humans? And she says, okay, I will destroy humans. So to me, that is literally a killer app for AI.
That is the
obviously
most
right. So obviously, I think
verbatim word.
conversational AI has improved significantly, and you probably won't get that answer out of a robot or a conversational AI tool today. Or maybe they're just better at keeping secrets before they, you know, our robot overlords come rule us. But anyway, jokes aside, you know, when I look at killer apps, I really think it's around image and video analytics where I see the greatest amount of traction and demand, because almost everybody has a camera, right? And a camera has, it's almost a universal sensor because there's just so much metadata embedded in every frame that that we humans process effortlessly, right? Because when you think about it, like a human eye is, you know, 570 megapixels, so it's 4x my Android phone, and we process it without even thinking about it. Computers have had a heck of a time doing that until AI came along, and even then, not too long ago, in 2012, Google Brain Project needed 16,000 computers to identify cat images on YouTube, because we know YouTube's full of cat videos, right? So it's a perfect training data set. That's the reason it exists, right? But now you think about it, your phone's doing that, right? How's your phone identifying and labeling images of photos that you take? Because it's using inference, and it's inferencing what is in the photo, so you can search using a text field and it shows photos of Christmas or whatnot, right? So, you know, the ability to do this AI and the ability to do it in a cost, power efficient, and a compact way on video and image data, that's a game changer. Because you think about retail, existing CCTV cameras, right? They all got 100 cameras in a big store, right? You can now look at shopper behavior. You can look at whether your shelves are full, you know, that they need restocking, theft, all kinds of stuff, right? If you're a manufacturer, I can look at products, reduce my defect rates, do that inspection earlier in the process when it's cheaper. You're just tapping onto an existing sensor that is there. All you're doing is a much higher order of analysis on it that AI enables you to do that, and do it in a way that doesn't break the bank, so you can turn a profit.
Yeah, I liken, so this, like, think about legacy surveillance. I just envision the security guard sitting behind like 12 screens eating a bucket,
right,
watching the cameras. It's like, you know, you can automate all that kind of stuff now, and you know, obviously drive new things as well. But so how, like, can I, from your perspective, you know, same question. I mean, what are you guys seeing as sort of like those first, you know, apps that make the most sense to drive at the edge?
I actually, you know, Bharat just caught me off guard. And I saw that video of Sophia, but it did not sink in until this very moment that yes, that robot wanted to kill humans.
Yeah.
To Bharat's point, I mean, I agree wholeheartedly that where video is today versus where even old school, like, the legacy pre-IP, like pre-smart cameras existed, right? So there is a lot happening just in vision enablement alone, where I see that I think these killer apps are also being defined by how do you use the vision capabilities, right? So where more and more now we are seeing that both computer visions and machine visions are being demanded to solve certain problems. And so Bharat talked about retail. So retail, definitely they're driving at least loss prevention and those type of techniques using vision enablement, using and some of the cameras have been leapfrogged to be able to run those inferencing algorithms, which by the way it didn't actually run a couple years back. So that itself is a revolution in my opinion. So that's one use. But going back to the fact that there are other sectors are also looking for that, what I would call killer apps, using the vision techniques, but to solve that sector specific problems. So if you look at, Bharat talked about manufacturing, so that's where we're seeing tremendous uptake in terms of how to use both the computer vision as well as the machine vision to address that basic problem that existed right at the assembly line, at the floor, factory floors, right? That's where edge AI, edge cloud becomes relevant, because you are now looking at developing a full scope solution that can run independently on that factory floor to address the defect detection. Now, if you go back 10 years, we did defect detection, but not truly in an edge native capabilities point of view that you are able to run just at the edge, meaning manufacturing or factory floor. Similar example, we are working across similar type of computer vision use cases across other sectors. So, energy and utilities. There is an interesting use case that we developed with a couple of partners for energy operators, right? And energy companies, where we literally are now bringing in real-time data from commercial grade drones, right? And helping to address as simple of a problem, it may sound like it existed for years, what we call vegetation management, where if you look at a simple problem that energy companies have to focus on really sending, the technicians a couple times a year to make sure the vegetation hasn't actually overgrown, to create a lot of natural problems in electric distributions. So now you're able to actually develop models, and even before you send out technicians, you can actually predict where the vegetation is growing at what rate and where we need to send and what frequency, right? So these addresses, as simple as using computer visions, right? The killer app is really to optimize workforce, so because that drives a lot of OpEx. So killer app I think a lot of times what we do, we take the basic capabilities and then try to address that very sector specific problems that can, something like computer vision help to address.
Yeah, cool. Yeah, so and there's a couple questions, and I'll try to put them in order of just the context of the conversation, which this is very related. So Paul asked, basically, to do edge AI, whether it's inferencing or training, you need to have more resources locally. And from an end perspective, user perspective, whether it's retail, quality control on a factory floor, how are end users at a point where they're able to kind of see the opportunity and justify the spend? It's kind of a chicken egg problem.
Yep.
I think we all as technology providers face that challenge. Bharat, like maybe your perspective, kind of what you're seeing, it's that if I invest, will I see the gains?
Yeah, so I think it really two metrics, right? It's either I reduce cost or increase my top line. Right? Yeah. It's really as simple as that. And a lot of customers start with, can I reduce cost by deploying AI? Because it's much easier to build a business case for cost reduction than it is to create a new business model to improve your top line revenue. And so, for example, in retail, right? One of the areas that we spend a lot of time working with customers on is reduction of shrinkage. Shrinkage in retail parlance is basically shop theft, right? And there's a portion of shop theft which is due to employees, and there's a portion of shop theft which happens because you have shoplifters coming in and to your Home Depot or Best Buy and just walking away with product. And historically, the way that these retailers have addressed that is by putting things like RFID tags on the product and having security in store. And while they all work to some extent, they're still not as effective, because if you look at the National Retail Federation, they're predicting roughly about 1.4% of annual gross revenues for a retailer is lost due to shrinkage, and about 50% of that is typically due to external shrinkage, which is shop theft. So that's a big number. Home Depot, 100 billion revenue a year, right? 0.5%, it's 500 million. That's a lot of money, right? And if they can invest enough compute in each store to use AI to address that, that's a big savings for them, and that's a pretty easy business case to build, right? So I think that's the purely looking at it from a financial standpoint. But there's also, the impact in terms of your policies and your organizational philosophies. Like, for example, facial recognition is a great way to know if a person's a shoplifter or not. But then it calls into question, are you now profiling the person? And if you do identify as a shoplifter, how are you going to address it? Are you going to have your store employee accost them and potentially put employees at risk? Or are you going to get law enforcement? And if that's the case, can law enforcement actually come quick enough to make a difference, right? Or is that person simply going to leave the store before the police arrive? So I think there's building the business case for cost reduction. I've seen this being the easy part, which a lot of customers can do. Retail is the example I provided. Manufacturing, same thing, right? If I can do more inspection and I can do that inspection more frequently and earlier in the process, it's pretty easy for them to come up with a cost of quality saving, because I'm reducing warranty returns, I'm reducing rework cost, etc. But then how do I do this in a way that for retail in this case protects privacy, avoids profiling, etc.? That becomes the harder argument. So cost reduction is really where we see them starting. But then there are also people who say, now that I have access to the data, can I create a new business model? For example, if I have data that shows how my pump is going to behave and the parameters that lead to failures of a component of a pump, and I can provide that prediction to my customer, I can charge for that capability, because if that prediction has value. I mean, I'd like to know my car is going to break down on Friday so I can fix it on the weekend, as opposed to the car dies on Monday when I'm driving to work, right? So the prediction has value, and these companies are saying, I have all this data, I have AI models, I'm running inference, can I monetize this data? And so there are cases for the revenue top line improvement as well, but we see a vast majority today still starting with, can I reduce cost, and how do I do that quickly?
Yeah, it makes sense. Yeah, and it's that notion of first start on kind of inward facing, clear cost reduction. It's a business case. You eliminate the person in front of the cameras, eating a bucket of chicken, watching the camera. It's like, kind of automate that stuff. And then of course there's the art of the possible of these kind of bigger use cases. Any kind of thoughts to add on that in terms of various verticals, use cases? Like, what's the progression in terms of order of investment? How do people justify it?
Absolutely. Same line, along the same line of thoughts, right? So we're seeing both cost reduction as well as new business model development almost in parallel. Cost reduction, I think, works effectively to develop the business case, because there are problems across different sectors that already have been in existence and it was never solved. The example, that shrinkage optimization, right, that has existed in retail for a number of years. And now, so if the retailers look at it from a cost reduction and optimization point of view, it is easily translatable. Whereas if you look at especially the automotive manufacturers and OEMs are investing in edge AI enablement, they're not only looking at improved quality inspection, how do you optimize downtime, right? Downtime prevention. In that process, add that predictive capabilities to understand how the health of what the product that they're building, how it's actually working, and how to maintain the health, right? But in the very same token, manufacturing industrials are also already looking at how to actually do that servitization, bring that added intelligence on top of their product as a bundled sort of offering to the end customers. So we see both both equation. However, I still feel that we haven't scratched the surface yet. I think there are customers across almost every single sectors where they're still trying to learn and understand that what it is AI can do. And so there are a lot of confusions around that as well. It's like, some of us industry peers, when we're talking, we're translating into not necessarily in terms of AI models, but we're literally getting down to explaining that, okay, how can predictive algorithms, right, help a manufacturer to understand that how the product that you have developed today, how it is behaving, and how we predict based on historical data and behavior and pattern, how we expect it to behave in next 3 to 5 years in that cycle. I think we have a lot to do in that translating the technical requirements into that translatable, I call it transferable business outcome. And that until that connection matures, I think it's very means we continue to need to educate our customers as well as as we work with the partners, if that helps.
Yeah, that makes sense. And so there is this sort of composite view that I think matters. I mean, a lot of people, from my perspective, a lot of people, well, a lot of people say they do AI and it's literally fancy rules engines, if this then that. So it's marketing. But as we see more kind of machine learning and kind of true AI inferencing coming down, that's key. But it's this notion of a system level approach. I've talked with a lot of customers in the past where it's like, hey, I could save you 30% of the time to do this part of your process. And they're like, cool, but if you don't fix my supply chain issues or other things, I don't see a net gain. I've still got parts I'm waiting on or something. And so it's how do you step back and take a bigger picture view? Another trend, so you guys, great points around, kind of the saving money versus like the new money, is compliance. Anything around, I always say people love to save money. They really hate to get fined. In terms of, so we see people doing things like flare detection in oil and gas and anything around how do I make sure that I'm meeting regulatory requirements? I think that's another easier business case than some of the new stuff. But anyway, so really good point. So and there's some other questions. Actually, one question. There's one around speech recognition that I think we'll get to when we talk about some of the challenges. And there's also this notion of kind of a memory at the edge from Luther. So we'll get to those here in a sec. David asked thoughts on use cases in healthcare, life sciences.
Very interesting. So Bharat, if I want to take, so I think I'm with SAS, so we have been very active in healthcare and life sciences for now a number of decades. However, I want to sift through the noise that in last 10, 20 years, what we have done also, what I would refer to as offline AI means, healthcare and life sciences had its own needs, and then you really didn't need what I called edge AI per se to be able to address those problems. But look at what we are going through. What happened due to the unfortunate situation, pandemic, there are areas in healthcare as well in life sciences that are demanding edge AI based application development, where you're having to look at how do I actually do readmission cost adjustment for the hospitals and providers if I were able to do remote patient monitoring? Now, RPM is a heavily invested and demanded area, especially within the last 2 years, which now it's almost like, how do you still care for patients at home, which is basically a hospital, outside a hospital, right? That type of demanding solution, right? All the way to connected devices, which still have to go through regulatory compliance, clinical trials, right? And these are FDA approved, especially for the US, and same regulatory compliance for the other countries and regions, so that you can bring the data much closer to the provider systems and then do the integration. So that's one aspect of healthcare. On the life science side, it's even more interesting. So if you look at on the life sciences side, what we have been doing on the what I call classic clinical trials, for the drugs and the entire process of the drug discovery through drug development. The classic clinical trial sort of solution now is under pressure to look at how does the pharmas and CROs can address what we call decentralized clinical trials for the drugs and medical devices. When it comes to decentralized clinical trials of these new drugs and new medical devices, I kind of think of DCT as a perfect amalgamation of bringing healthcare closer to life sciences. And that drives AIoT needs, right? So what I'm trying to refer to, so now the CROs and pharmas and medical device OEMs, now they are having to look at, okay, if I cannot bring sponsors and volunteer patients come in and help me to go through the clinical trial process in a very specific real state or a location, how do I do it remotely? So now all of a sudden DCT, decentralized clinical trial, and hybrid trials is far more complex and does demand for edge AI capability to address real-time processes in place to be able to do those clinical trial and go through that FDA compliance and regulations. So I hope those examples help. But I want to remind, these are very net new areas, right? We have talked about decentralized clinical trial even 3, 4, 5 years ago. All of a sudden, it is now far more important because of the situation we're in, because there are vaccines and being developed and there are other drugs being developed that does demand these real-time edge AI enablements, if that helps.
Yeah, that's cool. And I mean, obviously there's the bandwidth. I mean, when we talk about video, the only people that think it's a good idea to send raw video over the networks is people that sell you connectivity. Otherwise you want to process it locally. But you know, so there's other aspects, you know, bandwidth latency, of course, and then you get into, especially when you talk about healthcare, you know, things like data sovereignty and privacy and all that.
Yep.
Roth, any other questions on or comments on kind of the healthcare arena?
Yeah, I'd say healthcare data is probably your most private data, because you can change everything you can't change yourself. so you know, to me, it's like there's some really low hanging fruit. For example, medical imaging, right? Typically, when you go to your physician and you know you have a radiology scan, you know, ordered, the guy spends 30 seconds looking at your scan because that's all the time he has, right? Yeah. And in that 30 seconds, he has to come to the correct diagnosis, and he has to do it in a way that is defendable, because in case it is a, you know, cancerous or whatever, and he gets called behind, you know, in front of a malpractice board, the radiologist needs to be able to defend why he made, you know, that diagnosis or not. And so there's a lot of pressure, I think, in the radiology to be faster, to be more accurate, and to basically treat more patients and ensure better outcomes. And this is an area where it's a classic image recognition problem, because there are oodles of data around, you know, image analysis for, you know, lung cancer or cardiologists or whatever, and you know, people have done, you know, heuristical models on how you can use that to drive diagnosis. So it's not difficult to have an AI assistant who helps the radiologist. I don't think AI will ever be the radiologist, because people don't like being treated by computers. We like being treated by humans. But being an adjunct to the radiologist, so the radiologist is more effective and more focused, to me, it's an area where that's a low-hanging fruit that HPE and, you know, all our medical equipment partners, you know, the CT scanner makers, MRI manufacturers, are all going after. So that's an area where I see edge AI is unambiguously needed because of the criticality, but also because the data needs to stay local. I mean, I'm not going to send MRI scans across the internet, right? No matter how important, you know, I need to analyze it on. And then there's another area is really around remote healthcare, because you don't really have physicians available everywhere, especially in remote areas or developing countries. And, you know, so there's a lot of research around, can I create enough of an AI model that somebody who's not, you know, a doctor, like a trained physician, but who has enough medical knowledge, can look at symptoms and all of that, put it into that AI system and have it kind of give some guidance on treatment protocols. Understand that's not authoritative guidance because they're not a trained doctor, but at least it's better than no guidance at all and having them going off half-cocked with medications or whatever that might actually harm the patient, right? That's another area where that AI needs to be edge local, because you're talking remote locations, right? Could be a battlefield, could be, you know, a third world country, and there is no connectivity to a cloud and no connectivity to call somebody and say, how do I treat this patient?
Yeah. I do want to highlight one thing, even for healthcare or even any other sectors, right? There is this notion that when we talk about AI, not all models are based on vision. So we kind of really, and medical imaging is a different example, different types of example where obviously it is image intensive. But there are situations where it is basically data intensive and your algorithm is non-vision related algorithms, right? AI, machine learning algorithms. So those are still needed. If you look at the, the simple, all these medical device OEMs are going through this process because of pandemic situations where, they're coming up with a clinical grade medical devices that are being designed. I don't want to call it redesign, but designed to be able to use from outside hospitals, from outside clinics. And they're going through that process of getting approved. Those are still to be considered almost edge AI enabled devices. And they're doing it remotely. And we're going through that whole PII compliance, and that, what data can be exposed, what data cannot be exposed, right? It is creating as much of a challenge as much as I say opportunity, because we had this healthcare system where healthcare IT systems were really localized all the time, last 30, 40 years, right? And so every single time you went to a doctor or practitioner, you're almost having to reiterate who you are. And so we are trying to mitigate, because the need is now that, okay, how do I bring the data from other sources, which kind of proliferated because of the COVID-19 situations? And not only that, then how do I also make sure that the downstream systems, like, the EMRs and EHRs of the world, really actually being leveraged to have a holistic view of the patient? It is easier said than done, right? And so healthcare by default, it's a privacy sensitive area. I have seen, I think there are provider systems in hospitals and hospital systems. They don't want to even talk if you are not talking about edge AI, which data cannot even leave the premise of the provider systems. So hospital centric, right? I think European countries are much more, sensitive, and not that the US is not, but we are learning that process, because now we are having to look at data across the entire ecosystem, hospital and outside the hospital.
Yeah, yeah, and yeah, it makes sense. And I think, what's interesting with healthcare, and I want to move on to some of the practical realities in the real world, is telehealth has been emerging for 30 years, and then with COVID, it happened in 3 months, or actually probably 3 weeks. And so that necessity, or the trials that you mentioned, these new necessities, and just the forcing function of the unfortunate situation with COVID, I think has broken down the walls for more innovation in these types of things, whether it's the remote patient diagnostics that you said, Bharath. And so I think things that have been kind of like on the verge for years are going to start accelerating, because we've broken down some of those initial concerns. A lot of stuff to work out. Privacy is key. Of course, maintaining regulations, but I think we're going to see a lot of innovation coming soon. Okay, so we're at, and I know we've got some questions we want to get to that I'll fold in here as we go, but I've justified doing edge AI. How do I actually do it? What are the challenges, out when you try to deploy stuff out into the wild? Maybe Roth, I'll start with you. Obviously you guys, very familiar as a longstanding infrastructure provider, of like doing stuff in the real world is not the same. Plus, especially when you're not in the confines of a traditional data center where you can kind of go to one spot. So what are some of your thoughts on the challenges?
I'd say challenge number one is, how do I get to the dang data? Because when you go to the edge, you realize there's just so much data trapped inside siloed proprietary systems. They don't document the APIs. They don't tell you how you get the data out, especially in like manufacturing, oil and gas. I mean, there's equipment deployed over decades that has so much data that you could use to drive value for your business. Getting to the data is a pain, because even the simple wire you connect to that equipment is not an Ethernet cable. It's not a LAN cable. It's some serial protocol or some weird, CAN bus interface that your car uses to talk to its sensors. So challenge number one that we get asked for every time we go to a customer who wants to do edge AI is, how do I get to my data, right? And making it easy for them, not just the physical aspect of connecting to the equipment and pulling the data, but transforming that data into a normalized representation, so you don't care where that data came from. You just treat temperature the same, no matter whether it came from, a PLC from a particular vendor or a SCADA system. That is critical. Now we're seeing that improve. A lot of the modern deployments are starting to be Ethernet based, and the protocols are running over Ethernet. So it's improving, but it's still a far cry from where we want to be, right? It's kind of like the data center used to be 20, 30 years ago with the mishmash of Ethernet, fiber channels, SCSI, and all that stuff. So I would say that's problem number one, right? Problem number two is, okay, now I have the data. How do I make sure this data is free of noise? It's correctly labeled. It doesn't have bias, right? Especially a lot of concern today that, is my data, is my model somehow biased? Is it just going to discriminate based on, skin color or some other attribute inadvertently, because that's the biased data that was fed into the model, right? It's only doing what it was trained to do. So really having the ability to make AI trustworthy, which means scrubbing this data of all that bias and noise, making it robust, making it explainable, such that you can bet your business on it, that becomes problem number two. And then problem number three is, okay, so now I've developed this model, can I actually run it at the edge? Because the edge doesn't have the luxury of a data center or cloud where you have a lot of compute, a lot of memory, a lot of storage, right? Everything's constrained. You're operating in a space constrained environment, power is constrained, memory and CPU is constrained. So how do I cut down this model to the minimum level of accuracy and performance that it can run at that edge site, right? And how do I do that consistently at scale? Because not all the edges are equal. Some edges have more capacity, some have less, right? So how do I create that balance? And then finally, once I've deployed the model, I need to monitor it. I mean, this is not a one and done thing, right? Because you put the model out there, your data might change, the equipment it's monitoring might change, the people change, new insights and researches happen. So you want to be able to track what we call model drift, which is the model prediction starts to degrade. Track that and then be able to address it. Meaning, can I know why the model is not predicting as well as it should? Is it because my source data has changed and now I need to bring a subject matter expert in to relabel that data and retrain and improve that model? Or has it changed because something fundamentally, one of the assumptions I used is not really valid, right, at scale? So tracking this model drift, making sure that we can trigger that retraining and redeployment of the model in kind of a closed feedback loop, that is super important, because to do that, you probably need some level of core data center and cloud capabilities to do that training and retraining, right? Where you're having a centralized repository of data across your enterprise, looking across all your production lines, looking across all countries, and kind of bringing that data back to the center, right? So I think not only is it important to deploy Edge AI with good, clean data, with a well-optimized model, that needs to interoperate as a spectrum with the data center and cloud capabilities you might have for inferencing and training as well. And so really when customers come to us, it starts with, help me get to my data. Very quickly that turns into, how can I build an architecture that is operationally sustainable, not just today, but as my needs evolve over the next several years.
Yeah, definitely. And I think the drift is a key one because, you said things change in the physical world, lighting changes, someone knocks the camera,
right.
I mean, there's, whether it's, if it's vision or whatnot. So that's a key part of the overall life cycle. Huck, on your side, like other thoughts on kind of some of the challenges in the real world?
Absolutely. I mean, again, 100% in lockstep with Bharat's thought process. So, because we specialize in that data collection, right? And so where we're seeing the changes, and Bharat talked about, I think, 4 pointers, right? And I'm smiling here that number 3, that edge infrastructure, right? So where we're seeing now a lot of activities around the defining that edge, right? Can this edge be an hyper performance compute ready? So, and this is where I think infrastructure players are making heavy investments, where we as edge analytics providers are having to look at, because the definition of edge is changing. The constrained environment and now has the compute ready, or will have the compute ready processing power. So with that, and that's why I continue to emphasize on that. Now, when we are defining edge AI, we are really referring to edge AI on edge cloud. So it's almost like bring the necessary cloud-like environment at the edge. And that's what the edge cloud infrastructure will look like, where you will have the right amount of the necessary processing power and compute and storage, so that we can deploy the right type of application for the right scale. Now, The challenge still exists, right? When you're working with, let's say, let's go back to that example of manufacturing companies. um, Most of the tier one manufacturing companies, they have to worry about not only one manufacturing plant, they probably have anywhere between 50 to up to 200, 300 manufacturing plants globally. Now, if and almost the challenges are equally the same across all those locations. So even if you're working with a customer and developing the right, let's say, architecture and then coming up with the right models, how do you scale that across the board for that customer? That's still a challenge in terms of scaling it. That's number one. And number two, what Bharat was talking about as his last point, right? Model governance. That's where we have seen a tremendous amount of challenges with existing customers, right? So there's this notion over last, I would say 3, 4, 5 years, where a lot of even customers, right, have invested in data science capabilities and skills. To, okay, so it's just understanding, the data from the collected data and designing the right model based on the right algorithm, and I'm gonna just use it. Well, developing models and test that out in a proof of concept and a demo, and minimally viable scale deployment at 1 or 2 factory location is very different than really deployed at that scale. And then that's where the real work begins, as Bharat was highlighting, right? That how do you fine tune the model as you commercially deploy it, and then consistently actually understand if the model is performing what it was supposed to do. When the model starts decaying, how do you govern the model's health? Well, when the champion models become not champion, how do you transfer out the models, right? And so that model governance itself is a large area in edge AI. Now, when you actually have model governance, that can be at the edge, that also, the entire governance cycle can spread between edge and cloud. That depends on the customer itself and what problem we're trying to solve. But edge infrastructure is coming from the bottom up point of view, that where you're deploying those models, and versus the model governance itself is a life cycle issue of those models. So both are challenging when you think about the scale.
Yeah, that makes sense. Yeah, I've had a lot of people over the years. Well, data scientists say, I don't care where the data comes from. I just want clean data. It's like, well, you better care where it comes from, because if you don't know where it's been, then you can't really value it. And then the other one is these big architecture diagrams with like hubs and cloud, data lakes and yada yada in the back end, and this tiny box down below that says sensors, gateways, cameras, whatever. That's when I know you've not actually done one of these projects, because getting clean data out of the physical world is hard. But then you get into the advanced class around model drift and overall model lifecycle management. So one of the questions from Paul is, and I think that maybe I'll start with you, Bharath, is very much in line with what we're talking about. Do you think end users will start to look at ML AI at the edge as a necessary layer in the platforms they deploy to sites, so like basically part of the stack? Surely, Bharath, you've got some thoughts on that.
No, I think they don't need to think about it, because they're going to get it right with whatever they buy. Just like 20 years ago, you had to decide, do I want a sound card? Do I want a networking card in my PC? And today that's like a no-brainer. If you don't have it, nobody's going to buy it. So I think we're getting to a point where, at least for the inferencing piece, you're going to get AI inferencing capability in every device that you buy, whether you use it or not. And if you look at, let's pick Apple, right? All their phones have a neural network processor. All their MacBooks have one. You're going to see similar type of percolation of AI technologies into the enterprise CPUs, right? We're already seeing all the big vendors putting AI-specific application, AI-specific instructions into their CPUs, because their assumption is at some point AI is going to be so ubiquitous that it will be like any of the vector processing instructions, right? Everybody uses it today because it accelerates your workloads quite significantly. AI is going to be in that same realm where the benefits are so high that everybody's going to put it in their chips, and so the economic of being able to use the AI acceleration capability is going to be a no-brainer because you get it for free, right? So, short answer is yes. I think it's going to be a necessary layer. And because they have the capability, and they're going to be asked, why are you not using it if you're paying for it?
Yeah.
And this is going to be all the way up to the small itty bitty little devices at the edge, because you can put AI accelerators on Raspberry Pis today, right? So really you can get really small.
Yeah, even smaller. I mean, a lot of people kind of myopically, if you're kind of from the back end, you would say, AI, edge AI is like, kind of on-prem, even server or gateway level, but obviously TinyML is a hot topic right now. And we're seeing, even super constrained devices running, fixed models for fixed functions. And so that's just going to only evolve over time. Huck, any thoughts on kind of like, is AI ML tools, they're just basically part of the stack?
Absolutely. And for that very reason, we even actively had to look at is as the definition of edge was, I say in transit. And now we feel like that now kind of like, customer is defining, helping us to define where the edge is basically scoped and defined. So it's not only limited to that endpoint with the strictest, most hardware constrained, right, footprint, all the way to the big one. So I think I find Bharat's comment interesting, and that's where I think we also started thinking that especially the embedded and tiny MLs, right? These would become part of almost like capability stack, right? And so no matter where the edge is defined. And so I don't see that as separable entity anymore, because the more and more, all these, the customers and especially the hardware and device manufacturers are already kind of looking at that, how to expand that footprint to be able to run those inferencing on their targeted devices, right? No matter what that is, it is HPC versus non. I see that it's fundamentally critical for both AI vendors and the hardware vendors, and get much closer to make it embedded.
Yeah.
So I fully agree.
Yeah, I mean, I think, I've thought for a while, like eventually, as we're all saying, AI, but tools, machine learning, all the analytics, the core elements are part of infrastructure. It's there, it's ubiquitous. Where the differentiation will lie in all of this is how do you deliver the infrastructure? So things as a service, whatnot. How do you generate kind of low code, no code tools to where it's easier for people to consume it? Because ultimately it's about, that's infrastructure, and then it's about how you apply it, what domain knowledge you apply, what use cases, and how you service it up to your end users. So I think that we're all kind of in agreement that this is an infrastructure play long term, and then from there you enable with all the bells and whistles. The core stuff is gonna. So I was going to mention, so Jags with latent AI just asked a question. Which exactly what I was saying. How does the panel think about managed services for edge AI? Kind of right along the same lines. Thoughts?
I always say that look, we can conceptually build an end-to-end solution that leverages edge AI if there are cloud pieces, but if we cannot deliver that at scale, and that's where I kind of like I had a point on my notes today for today's call, that I still believe fundamentally both MSPs and SIs are gonna step up, because at the end of the day, just the way to Bharat's point, and I highlighted that model governance, right? As ISVs and hardware OEMs, once we actually build that capability to enable edge AI for, let's say, a targeted sector manufacturing, they still have to have OpEx involved with that, right? And so I think the managed services offering makes most sense, because it's that continuous improvement on those models, right? That's the variable piece, and rest of the piece stays constant. It grows only as the businesses grows, right? The infrastructure itself, you need more infrastructure, you need more capabilities. However, that variable piece, that the model governance on that riding on top of that infrastructure, it needs continuous care and loving, right? And so that's where that managed servicing offering we foresee that makes total sense. Otherwise, what we anticipate, that you cannot just build these and deliver these for your customers and walk away, because it does need that post deployment, post delivery managed services sort of offering.
Yeah, Roth, your thoughts on your end?
Yeah, the way I look at it is, who are we selling to at the edge, right? And you think about, when I look at the edge, I see two distinct type of personas, right? So one persona are the line of business, who frankly don't care about the technology. They'll gripe about it if it fails, but if technology works, they're just going to ignore it, right? So when you're selling into them, simplicity is the name of the game. And today, if you need a data scientist to sit and babysit every single project, that's not something that's going to gain good adoption, right? But that's changing. So creating that low-live, no-code, low-code type of way where a line of business user, a QA tech, or somebody in loss prevention for the store can build and deploy those AI models is important. But that is not the entirety of the story, because when you're doing this kind of infrastructure deployment, you want to do it covering a multitude of use cases. And that's where really I see the managed services piece coming into play, because AI infrastructure is getting commoditized, right? It makes no bones about it, because it doesn't cost you a lot of money. It's not really difficult today to go find AI-enabled hardware you can deploy at the edge. So the hardware is getting commoditized. It's getting more and more looking more and more like compute infrastructure you deploy for other types of workloads. Could be SCADA systems, could be retail point of sale, databases, and all of that. So managed service offering makes complete sense, because many cases they're already doing that for their IT workloads. And now they're saying, let's extend that paradigm to the edge. So infrastructure and platform management becomes less of a concern to the edge customer. It's more, what is the workload that I'm running and what is the outcome that I'm getting out of there? So I definitely see there's an opportunity for managed services. I think that's being driven by the fact the customer doesn't want to worry about the technology, but also the fact that technology itself is getting so commoditized that the MSPs have economy of scale, and they're not having to build a unique architecture for every single customer they go after just because they're doing AI.
Yeah, makes sense.
Bharat might be referring to that easy button.
Easy button, that's right.
Yeah, exactly.
So we've got a couple minutes left, and actually this other question kind of plays right into this. I did want to touch more on the privacy aspect, and we talked a little bit about it during the healthcare component, but question here is, so I've got public edges being developed with of course AI capabilities, like look at AWS Wavelength. And so if I'm a managed service provider and I'm providing services, say not just to a given business under contract, but to a lot of folks as more public infrastructure, what are your thoughts on how do you handle kind of that boundary between around privacy and security? There's a slippery slope when you go kind of one to many versus of different stakeholders versus one to you, or do you see that really taking off? Do you see more of kind of like third-party providers, sort of direct relationships, or and we've got 2 minutes to answer that question.
So I'll try my best to take 30 seconds. Jason, I still think that is still being fleshed out. Yeah. If you look at a high level, right, I see fundamentally there are applications are appropriate for that public edge infrastructure, right? That's where you are also going to see the telco 4G and 5G based telco edge cloud takeover on the public side. However, there are applications that are being demanded that will not touch anything other than private edge clouds. And so it is being fleshed out, right? And so now that doesn't mean even if you deploy on private edge cloud, it's not going to have backhaul using a public edge cloud. That's going to be only for sort of like a backhauling and connecting distributed points, distributed centers, right? But the actual edge cloud-based applications, I more foresee it's a self-healing systems contained, and that's how you're going to address to make sure that it has the privacy address, it has the control, it has the latency awareness that is being demanded and things like that. But then again, the customer need is going to drive, is it truly public? Is it truly private? Is it public with dedicated, or is it hybrid?
Yeah.
See, the way I look at it is that at some point you have to trade off privacy in exchange for the benefit of AI, right? And because it's a natural balancing act, right? Now, how much you give up really depends on your tolerance, right? It kind of reminds me of an episode of Black Mirror. I don't know if you watched that Netflix show, right? Very dystopian, quite thought-provoking, sometimes very disturbing. There's this episode where, this mom wants to protect her daughter, and she puts like an AI chip in her brain that filters out any bad images, bad TV scenes, things like that, right? So obviously that's really far-fetched, but the thinking is like, what are you willing to give up in terms of privacy in exchange for protection that AI is going to deliver? And is that AI inadvertently going to end up shaping and controlling your behavior? Because that is a real concern today, right? I mean, most of us are aware of the social media bubble where your personalized news feed is kind of shaped by your interest and what you like, and that drives the polarization of society. I think there are millions of academic papers being written around this. And ironically, AI might actually be the solution to that, right? Because it does know sometimes when you're biased, and it's able to provide, counter points to kind of bring you back to the center. But as the customer, as the end provider of that AI capability, the buck stops with you, right? You might be running on an AWS wavelength, but what is the workload that you're deploying that is in your control? And being able to ensure explainability of why your model is making those predictions is going to be critical, because when you don't have that kind of transparency and explainability, you can get into a lot of trouble. Like in Europe, for example, with GDPR, they're saying that if you have an AI algorithm that's doing automated decisions that impact things like your job, your credit, insurance, you need to have a recourse where if I get denied my loan, I should be able to talk to a human who can tell me why the model got to the decision that it got to, right? Be able to explain it. So they're going to make it a legal requirement that the model you're running needs to be explainable, and you need to prove that it's fair, or you can be legally liable, right? So which infrastructure you run on, is it a public cloud infrastructure? Is it a private cloud? Less important to me. Those are kind of problems we can still deal with. How are you going to explain that why your model predicted the way it predicted, and prove that you did all reasonable steps to keep the model unbiased and fair is going to be critical. And I see customers being really worried about that piece, right? And that's actually, I would say, an inhibitor to a lot of them deploying AI quickly, is because they want to get ahead of these kind of legal pitfalls.
Yeah, it makes sense. So we're at time. This has been a really good conversation. I saw Ross has a question around how do software providers compete in this space, and I think it's I'll just say my thoughts real quick in the interest of time. It's focus on the value, focus on services, don't focus on the plumbing. Really low code, no code, make it easier to consume. That type of stuff. Not that core infrastructure. You wrap it all up into a managed service. Whatever. I think that sort of summarizes what we've been saying in general. And actually, Broth, your comments around, sort of the ethics side of AI and the trust factor is a great segue in the fact that we have our next Transform Digest on December 16th is around trust fabrics, this notion of system level trust, and this is advanced class. Once we get past we talked about just get to the data, figure out how to deploy my model, do model lifecycle management, and then how can you mention this notion of now I got to look at my entire business across a global operation. Advanced class is does the data and the analytics that I drive relate to other people's data analytics and these interconnected ecosystems. So that'll be a topic that definitely has the privacy component. And then Broth, as you said, if you trust the entity giving you value, you'll give up some privacy. And so that's that fine balance that we'll see over time. So tune in on the 16th for Trust Fabrics. We've got the theme song for that one ready to go. If you guys have seen the silly theme song we've been doing online, it's a fun one. But really appreciate everyone for joining, and thanks Huck and Broth for lending your expertise for this one. I thought it was a great discussion, and really appreciate the engagement online in terms of various questions from the audience. So with that, I will sign off, and you guys have a good day, and thanks again everybody.
You too.
Thanks.
Thank you,
that was
guys.
fun. Thanks, Jason.
Thank you. Bye-bye.
All right.